Hello. Sorry for the glitch. Actually, due to some technical issue, the meeting got disconnected. Now we are again here. Uh, Sir, are you here? Are you able to hear me? Professor Agarwal? Yeah. Yes, sir, we are just doing. Sir, you can unmute yourself. Yes, sir.
Uh,
You are audible, sir. You can share your screen. Sorry for the glitch, sir.
but you have to tell me at what point this interruption has taken place.
Okay. Let me just tell you the slide number, sir. Just wait. It was on 38th or 39th slide, sir.
Okay. But 38 or 39, huh?
Yes. Where the handwritten digits was, you were telling the example.
Okay. All right. Okay. So 39, I had explained about how face is being recognized.
Yes, sir.
So I have to start from convolutional neural network, I hope.
Yes,
है ना?
sir. Yes,
Okay.
sir.
So first of all, I'll ask to the audience, are you getting things?
Audience, if you have any query, please raise your hands. We will unmute you. Yes, sir. Actually, they are interacting via the chat window.
At least you allow them, one or two persons.
Yes,
है ना?
yes, sir. We are allowing them actually. I'm just.
You can take at least one or two so that I
Yes, sir.
understand.
We have allowed the mic for everyone in the
Okay.
participant side. So
हाँ.
those who want to ask something, they can unmute and they can ask.
Rakhi ma'am, you can
Yes, ma'am.
unmute Alka ma'am.
Yes,
She
ma'am.
can communicate.
We
Alka
we
Litha
have
or Aarti
we
ma'am.
have unmuted everyone, ma'am. They
Okay.
can unmute themselves by themselves and they can ask.
Any query?
Good afternoon, sir.
Good afternoon.
Sir, session was going very nice. You are talking about the segmentation process and using unit. And the last slide we discussed that was regarding the segmentation part where the face you are segmenting in different parts and explaining the things. We further want to know about the model that is the unit that you
No, that I'll discuss. But what I'm asking, are you getting things?
Yes, sir. Yes, sir.
Means everything is clear till now, whatever I have covered.
Definitely, sir.
So then let me start again with convolutional neural network. Is it fine? Okay.
Yes, sir.
Okay. Any other query from any participant? No. Okay. So since there is no query, we'll take up queries once I finished my presentation. Is it fine? Okay.
Yes, sir.
So I'm sharing my presentation. You just see that whether it's visible or not. Is it
It is
visible?
visible, sir. Yes, sir. It
And
is
it is
visible.
moving also?
Yes, sir.
Okay, fine. Okay. So to explain how convolutional neural network works, okay? So you can see that in convolutional neural network, there are two very important component. One is your how convolution between image and filter takes place. Now you unmute them.
రమేష్
Now you
కుమార్ గారు
unmute all of them.
ఫోన్ చేసి ఆయనకి ఏం చెప్పానంటే సార్ యాక్చువల్లీ వర్క్ షాప్స్ గెస్ట్ లెక్చర్స్ అని వేసారు ఓ పక్క నుంచి ఈవెంట్ కోఆర్డినేషన్ చూసారు ప్రొఫెషనల్ బట్టి ఇన్నిటి మీద నేను హారిక తీసేసి కదా వేసాను
आप
వర్క్
अनम्यूट
ఎక్కువ
करो सबको.
ఇచ్చేసాను చెప్పాను
Sir, we have unmuted everyone, muted everyone. Sir, please, could you unmute yourself now? Because along with all the participants, we
नहीं,
have been.
हाँ चलो हो
Yes,
गया.
yes, fine,
Okay,
fine.
okay.
Okay, thank you, sir.
Next time you assign different ID to the speaker.
Okay, sir.
Okay.
Okay, fine.
हाँ.
Fine.
Okay. I
Thank
think
That would be
that's how
fine.
you'll be
Yes,
able
sir.
to control in a better way.
Yes, sir.
Okay. Okay. So I'm going to explain two important process of convolutional neural network. One is convolution. Another is your pooling, or we say subsampling. Okay. So let's understand these two process first. So if you have an image, which is, let's say this is your image, and these are the pixel values. And let's say you have a filter with these weights. So if I say convolution between this image and filter, then what happens is I bring this filter and align this filter with the starting location of the image. And at this point, I take dot product. So what is the dot product of this subregion with this filter? 1 into 1 plus 0 into -1 plus 0 into -1, similarly 1 into 1. So the net value will be your, after dot product, it will be 3. So then I'm going to move this filter by one column right or one column, one row down. So let's see if I move by one column right, say stride of size 1, I'll be here. Again, I compute a dot product at this point, and you can see that this dot product is -1. If instead of stride of size 1, if I have moved by stride of size 2, then the situation would have been like this. Means here, by moving the filter by 2 column right, I compute the dot product. Means by how many columns I am moving to the right, or by I'm moving the rows down. Okay. So stride size will determine by that. If stride is of size 2, means I can move by 2 columns right or by 2 rows down. I'll explain this with the help of only stride of size 1. So I compute this dot product here, then this, then my move, I compute this dot product, I move by one column right, I again compute the dot product, I move one row down, I come here, I compute this value, and in this way I'll be able to compute the convolution between image and this filter. Okay. One interesting fact you can see that in this image, this is the pattern. One is diagonally placed, and all other neighbors are having value zeros. Here also you can see diagonally placed numbers are 1 and all other adjoining values are zeros. And at this place, at this location, the value of convolution is 3, 3. Okay. So this filter can capture one kind of pattern present in the image. But you can see there is another kind of pattern, which is this. There is another kind of pattern, which is this. So for this, you require different filter, and for this, you require different filter. So let's say if I take another filter, filter 2, now you see that it is going to capture this pattern. And corresponding to this, you will have maximum value at this location. Okay? Which is 3. So you think about when you are having an image, you are convolving an image with a filter. So one filter can capture only one kind of pattern. But image can have many kind of patterns. Image can have edges of many different orientation. So then you require different filters to capture different patterns or different edges present in the image. So I think I was able to explain what is your convolution does. With the help of convolution, you are trying to extract different kind of features associated with the image or different kind of patterns associated with the image. Then what you do in pooling? So let's say after convolution, we are going to use subsampling, pooling of different kind. So let's say if after filter 1, I got this output. After filter 2, I got this convolution output. So in pooling, I divide this obtained feature map into many blocks. Let's say I have divided this feature map into block of size 2 by 2. I can make it 3 by 3 also. I can make 4 by 4 also. So after making different blocks, in max pooling, I retain only maximum value. So what is the maximum value here? 3. What is the maximum value here? 0. What is the maximum value here? 3. What is the maximum value here? 1. So after max pooling, what will happen? From each block, I'm capturing your maximum value. Thereby, I'm able to reduce the size of the image and I'm retaining relevant feature associated with the image. Similarly, I can do it with the second feature map. Okay. So you can see that what we do in pooling, but what is the effect of pooling? So I have carried out this max pooling on this image without any convolution. And I got this. Can you see this? Both birds present in the image are same. Background remains the same. Trees remain the same. Color of the tree, color of the bird remains the same. So we are not losing any relevant information. Only what is we are happening, this image which was represented by initially m by n pixels, now it will be represented by m by 2 into n by 2 pixels. So using pooling, I'll be reducing the number of features to represent the image. I hope you have understood this part. Okay. Okay. Now, so there can be many kind of pooling. From the block, I can associate average value. I can take median value. I can take L2 value, L2 norm value. I can take max value. I can think about some other kind of functions also to represent that block by one single value. Okay. So now let's see what we do in convolutional neural network. This was the first architecture suggested by Lee et al. Work, where there is an image and the image was of size 32 by 32. And there were 10 different class of images present in the database. And first, in this architecture, they have used 6 different convolution filter. And the size of this convolution filter is of size 5 by 5. Okay. So when you apply convolution, each convolution will give you one feature map. Means it will give you one kind of feature. It will give you one kind of pattern present in the image. But I want to reduce the size of the image. So what I will do? I'll use pooling. Either max pooling, L2 pooling, min pooling, average pooling. So each feature map is of size 28 by 28. But by considering block of size 2 by 2 and retaining only maximum value, my image size will reduce to 14 by 14. So each feature map, okay, size will reduce from 28 by 28 to 14 by 14. So by this process, what we have done? By using different convolution filter, I have captured different, and to reduce the size of the pattern, I have used pooling. I further use 16 convolution filter so that I can combine the learned features at this stage to learn more complex features. So if I combine one horizontal edge with one vertical edge, I'll get different pattern. I'll combine one vertical edge with 45-degree edge, I'll get different pattern. So I combine these feature maps in a different way using convolution to capture different complex pattern associated in the image. So I'll obtain 16 feature maps. I'll further use pooling. So size will reduce to half. So this image was of size 10 by 10 and it will reduce to 5 by 5. Again, I use convolution to learn more complex features. Say I use 120 convolution filters. So I'll obtain each convolution filter will give you one feature. So from this image, after first convolution, pooling, second convolution, pooling, and third convolution, I obtain 120 features. Now you think about this is your neural network. You use 84 hidden nodes here. 10 for 10 class, I use 10 nodes at this layer. Every input node of this C5 layer is connected to every nodes of F6 layer, and every node of F6 layer is connected with every node of output layer. So what you do? You pass the input, you obtain the output, and if the obtained output is different from target output, what you will do? You will change the weights. Which weights? Weights of the convolution filter, because this is not known to you. You have to learn these weights. So initially, each filter will be assigned random weights. Based on these random weights of convolution filter, you compute the output. And if the output is different from target output, using gradient descent method or its variants, you change the weights of convolution filters. Okay. But what is the advantage? The advantage is that convolutional neural network you utilize lesser number of weights in comparison to neural network. Okay. Okay. Neural network require larger number of parameters in comparison to convolutional neural network. So that is the advantage. Okay. So that you will be able to carry out the same task with lesser computational power, and performance of this convolutional neural network will be better than neural network. The other reason that neural network gives better performance than neural network is that neural network does not retains topological information of the image data, but convolutional neural network retains topology of pixels information. Okay. So this I have already explained. Okay. Okay. Now, let's learn UNet model. So convolutional neural network was designed for classification. Say you have images of different kind of objects. It means you have either dog, a cat, bat, rat, mouse, lion, tiger, and you want to find out that in a given image which object is present. So you're trying to classify. But when I talk about segmentation, we are not talking about classification. We are talking about you are dividing the image into a set of subregions, where each subregion will have a similar kind of pixel values. So if you use the convolutional neural network for image segmentation, then we can do it. It's not that we cannot do it. So let's say if you have 3 kinds of pixels associated, what you can do, the output size in CNN will be same as the input size of the image, and you use the ground truth, and we can learn the weights. But the number of weights which you need to learn for image segmentation will be too much. So now let's see, there was a model which was UNet, which was suggested, and it was basically motivated by the research work of convolutional neural network and another architecture, that is your fully convolutional neural network, FCN. So let's understand what is this UNet model and how it is able to carry out image segmentation. So you think about, you are given an image of size 48 by 48 by 1. And let's say this image has segmented output, which is known to you. That is your ground truth is available to you. But this ground truth have values either A or B or C or D. Okay. So a group of pixels having values a group of pixels having values B or C or D similarly. Since my name of this architecture is UNet, and because it has U shape, okay. So this model, we think about this is a U shape. That's why the name is said UNet, okay. U-shaped neural network architecture, okay. And in this UNet architecture, basically there are 2 main components. One is your encoding path. We also say contracting path. And another is your decoding path. So what you do is, initially given input image, using convolution filters and pooling, you are trying to learn relevant features of the image present in the image. Means using the same process of convolution pooling, I am learning complex features, okay, present in the image. But since I am reducing the size of the image, I don't know where are these complex features present in my original image. And to find out where are these features present in the original image, I use decoding path. We also say expanding path. So what we do, using this relevant features, I again do convolution and upsampling. Earlier I was doing downsampling, but now I talk about upsampling. So that I increase the size of the image as we move upward and keep on increasing till my size of the image is same as the size of the original image. So I'll explain this with the help of example. Okay. So you think about, you have an image of size 48 by 48 by 1. I apply 32 convolution filters. You say, why 32 convolution filter? Because each convolution filter will learn one kind of pattern present in the image. And so I will have 32 feature maps. Each feature map will be of size 48 by 48. But then I do downsampling, pooling. In pooling, what will happen? In downsampling, image size will get reduced to half. So 48 by 48 image size will reduce to 24 by 24. But the number of feature maps will remain the same, that is 32. Again, on these 32 feature maps, I apply 64 different convolution filters. So I'll learn more complex features. I'll obtain 64 convolution feature maps. And again, I do downsampling. So image size will reduce to 12 by 12 and the number of feature maps will remain 64. Again, I apply convolution filters. Number of convolution filters I'm increasing, doubling. Okay, 32, 64, then 128. Okay, and then I'm reducing the size of the image through downsampling. So now I have 128 feature maps, each of size 6 by 6. Again, I do convolution, 256 convolution filters. And again, I do downsampling. So I'm going to obtain your 256 feature maps, each of size 3 by 3. So you can see in this encoding path, what I'm doing, I'm using convolution filter to learn features, and I use downsampling to reduce the size of the image. So your original image, which was of size of 48 by 48 by 1, is reduced to 3 by 3 by 256. Means I am learning a feature which is described by 3 by 3 image, but I'm learning 256 different kind of features. And now using these learned relevant features, I going to map where these features are present in the image. And for this, what I do, I further do convolution. Okay. And now let's say this is your 502 convolutions. So I'll obtain 512 feature map. Okay. And then I do upsampling. So when I do upsampling, the number of feature maps will remain same, but the size will increase to double. So 3 by 3 will increase to 6 by 6 feature maps. So here I have your 6 by 6 512 feature maps. Okay. And I utilize. So at this stage, what I do, the features which I learned here are also utilized using a skip connection. I combine these, okay, with this, and I obtained feature maps of size 6 by 6, and the number of feature maps will remain 256. So in this path, I keep on expanding the image size by upsampling, followed by convolutions, and at the last I will obtain, let's say, 48 by 48 image size, 32 feature maps, and further I combine these 32 feature maps as one feature maps, okay, and I'll be obtaining an image of size 48 by 48 by 1. So can you see that segmented image output is same as the input image size? Now I know what each pixel represent. Okay. So this is one of the very popular model which is being used these days. And now people are making modification in this model to suggest improvement in this unit model. So I'll suggest one such model which was suggested in one of the work, and that was your me unit. Because in unit, you were seeing that with depth, I was increasing the number of convolution filter. But in this case, it was suggested that instead of increasing the number of convolution filters, I will decrease the number of convolution filters. So if you are decreasing the number of convolution filters, definitely the number of parameters involved in me unit is less than unit, but the performance of me unit is less in comparison to unit in terms of accuracy. Okay. Then people have suggested a better way to improve, and the model was ITER unit model. And in this ITER unit model, what is suggested is that you think about the output of one unit is given as input to another unit, and the output of the second unit is given as input or to the third unit to refine the output. Means I obtain some output by one unit model, and I further improve the output of this by using successive units, where each successive unit will consider input of the previous output of unit. Okay, and it was observed that the performance of each unit is definitely better than both unit and me unit, while the computation time of each unit is more than both unit and me unit. Okay, all right. Then we have also suggested one architecture. Okay, and we have suggested ITER me unit model, where instead of using unit, we thought of using me unit, and we have refined the output of me unit by ITER unit. So thereby, what we have seen is we have performed the experiments of our proposed model on 3 publicly available datasets. Those are drive datasets, stare datasets, and chase DB datasets for vessel extraction of retinal images. So can you see that these are original image of retina, and these are the ground truth. And I'm showing the output of this ITER-me unit, then Ethernet, then recurrent unit, me unit, and unit. Okay, for different images. If you see in terms of area under curve, your sensitivity, specificity, accuracy, and F1 score. So you can see that I have shown the results on drive datasets, state datasets, and chase DB1 datasets also, where you found that in terms of AUC, your ITER-me unit has outperformed all other models on a drive datasets. And similarly, the performance of ITER-me unit is better in comparison to other models on chase DB1 datasets also. We cannot say that in all terms of all performance method, our method is giving better result than the best model of state of art. But what was seen is that the performance obtained is either better or little less than existing best result of state of art. But in terms of training and inference time, the performance of ITER-me unit, you can see, is significantly better than UNet, recurrent net, and Ethernet. Similarly, in terms of training time also, it is better than all models except me UNet. And similarly, in terms of inference time also, the performance of the proposed model is better in comparison to all models in comparison to me UNet. But the performance of me unit is inferior among all models. Okay. Okay. So we have also compared the results of the proposed model with other different models. Okay. Okay. I think that's all from my side. Okay. If you want, this work is published at Multimedia Tools and Applications. All those who are interested in knowing the details, they can look into Multimedia Tools and Applications, which are published by Springer. Okay. So thank you all for patient hearing. Okay. And now I am available for questions if you have any questions.
Thank you so much, sir. Participants, you can ask if any questions are there from the participant side. Any participant want to ask any question?
No questions?
No doubt so far. Sir, actually in chat, the participants are writing. Everything is well explained. No
Then I
doubt.
think it would be better they should come one to one. Okay.
Yes, sir.
You,
Please
you
raise your
allow
hands
them.
if you
Okay.
want. Yes, sir. We will allow those who raise their hands and we will unmute them. Please raise your hands if you want to ask something. We will unmute you. Sir, one question is there. Jyoti ma'am, I am unmuting you. You can interact.
You can ask. It is better.
Yes, yes. Yes, yes. That would be fine, sir.
So she can ask.
Yes. Jyoti ma'am, you are unmuted. You can ask.
Hello. Hello.
Yes,
Yes.
ma'am, you are audible.
Good evening, sir.
Good evening.
Sir, I just wanted to ask that we did not see any padding in the CNN networks that you explained.
Actually, do you know what is the role of padding?
Yes, sir.
The role of padding is that if you after convolution, whether you want to keep the output of the feature map to be same or not. Okay. So if you want to keep the output of the feature map same as the input image, in that case I do padding. All right. Have you understood?
Okay, sir. Okay, sir. So in this case, we did not need the same size. That is why we did not.
Yes.
Okay. So if does it impact the performance? Does it have any relation with the performance?
No, because what we are doing by convolution, we are learning the features. Okay. And at the boundary, okay, the padding can be done in many ways. When we are doing padding, we are giving false information in the padding. So it is not going to actually help in learning something relevant features which we are losing. So there is no need of keeping padding. You can keep it or you may not keep it. Is it fine?
Okay. Thank you, sir.
Okay.
Alka ma'am, you can unmute yourself.
Hello. Sir, is there any method that is available to index the feature map?
To?
Index the feature map.
Yes, you can write a code. It's not a method. You don't require any method. We can do coding at our end itself.
Okay.
What you are saying is that what is the position of the pixel in the image? That's what you are saying indexing?
Yeah, sir. It's difficult to do the indexing at 512 because that will create so much computation.
No, there is no. I think in data structure we teach that if you are having two-dimensional arrays, how to compute indexing of two-dimensional array elements. There are two different forms. One is your row equivalent form, another is your column equivalent form.
Okay.
Okay. So finding out indexing is very straightforward.
Fine.
Is it fine?
Yes, sir. Yes. Thank you so much.
Okay. So Jayashri, Jayashri, why don't you? You may
ask. Yes, sir. I have unmuted her. She can switch on her mic and she can ask. Jayashri ma'am, you can unmute yourself.
Yes, ma'am. Yes, ma'am. Good afternoon, sir. It was very interesting session, sir. But sir, when I have read this CNN, sir, flattening. What flattening in CNN?
I'll make you understand. You just see that while I was explaining with the help of example in CNN. Okay.
Yeah.
What I did, you have an image. I upload applied convolution.
Ji.
I learned one kind of feature. Then I reduce the size of the feature map by using pooling.
Yes, sir.
Then I further use convolution. Why? To learn more complex features.
Yes,
I
sir.
further
Yes.
get it reduced. Again, I use convolution. I further reduce the features. Yes or no?
Okay, at every step.
Oh,
Yes,
okay.
yes.
So let's say you assume that each feature map, you have 10 feature maps at the last layer, till now. Let's say only there are, let's say 100 feature maps are there.
Yes,
And
sir.
each feature map is associated with 3 by 3 pixels. Then when you say flattening, flattening means that your image will be now represented as one-dimensional data. Okay.
Okay.
So your each feature map is of size 3 by 3. So if you do flattening, what is the size of the feature? 9.
3 by 3, 9.
And how many such feature maps you have? 100.
100.
So you
9.
combine them, combine one after the another. So what is now after flattening? How many features you have now? 900.
Yes, 900. Yes,
Okay.
I understand.
So you think like that these are the 900 features which represent your input image. Now you think about neural network. What do you used to do? You keep one hidden layer. You connect every nodes of these flattened nodes with the hidden layer. Every node of hidden layer is connected to the output layer.
Right, sir. Right, sir.
Okay, so flattened layer means you are converting the data which is in the form of image into your one-dimensional data. Is it fine?
Okay. Okay, sir. I understand. Thank you so much.
Okay.
Any other participant want to ask questions? Please raise your hand. We will unmute you. Jyoti ma'am, you are already allowed for the mic.
Yes, ma'am. Sir, I just wanted to understand if CNN is also, it is also useful for 3D images and video frame analysis also.
Yes. Yes.
Then
What do
how
you
does it do that? I mean,
so
for a
so so
2D image.
let's say CNN is used for video. Okay? Are you getting? Let's say what is video? Do you think video is a set of frames where each frame is an image? Where each frame is image?
Yes, sir.
So in the case of image, the size of the convolution filter is 2-dimensional filter. But in the case of videos, you can think about that the convolution filter is your 3-dimensional convolution filter. Okay.
Okay. So that means the filters would change according to the kind of image that we have.
So let's say if you have one-dimensional data, audio data, you have audio data. Okay. So audio data has only one single value changing with time. So what is the filter size? It will be one-dimensional filter. You can say 1 cross F. Okay, you can
So
think
we
about.
can. That means we can use CNN for audio also.
Yes, people are using it. People are using this CNN architecture to process audio signal, speech signal, ECG signal, EEG signals. Okay. And similarly, for they have extended for 3-dimensional data also. Now it can be processed for video data. You talk about MRI volume. So what is the MRI volume of brain? Again, this is a 3-dimensional data. No. Your MRI brain of the volume will be what? 3-dimensional?
Yes, sir.
So people are using convolutional neural network. But what you need to change? Your convolution filter will change appropriately, accordingly. Okay? Now you'll have to use 3-dimensional filter for that.
Okay. Thank you, sir.
Okay. Any more question?
Any other participant? Please raise your hand. I think, sir. Okay. I think no more questions from the participant side, sir. Thank you, sir, for such an informative and enlightening session. And we are truly apologize for that technical glitch. Actually, yeah. Okay.
But
Thank you
at
so
least
much, sir.
it's for better
Yes, sir. Yes, sir. The
functioning.
suggestion is
It's
taken. Yes, sir.
better that you keep for speaker and for
Yes, sir.
participants.
That I do.
You two types. Okay.
Yes,
All
sir.
right.
Yes, sir. Thank you, sir.
Okay.
Thank you so
Okay.
much.
Okay. Bye.
There is one more announcement for the participants. We are getting queries regarding attendance. For attendance, actually, from the Microsoft Teams side, what we are getting, the recorded attendance, we are marking them. If any query is there, we will sort it out after Saturday, after the ending of this particular meeting, because we will get the full attendance record from Monday to Saturday on Saturday itself. So please be patient regarding the attendance. We will handle it and we will sort it out. So till Saturday, please maintain. If someone is marked absent, then in that case, if you have messaged us, then we will surely correct it. Okay. Thank you so much for this engagement for today, because we were having 3 sessions today, and we will look forward for the tomorrow session with the same enthusiasm and same energy. Thank you. Have a great day.